So this problem we're going to start with part A using traditional factoring methods. We're going to do it using only our Algebra 2 techniques. So the equation is actually a difference of cubes. We can rewrite, it's supposed to say cubes. We can rewrite the equation as something cubed minus something cubed. And it's actually z squared cubed minus 4 cubed. And the difference of cubes pattern says that if you have a cubed minus b cubed, the factors are a minus b times a squared plus ab plus b squared. So following that pattern, we have that the factors would be z squared minus 4 times z squared plus z squared squared plus 4z squared plus 16. And z squared squared becomes z to the 4th power. Both of these equal 0, so I'm going to set both factors equal to 0. I'm changing z squared squared to be z to the 4th. Okay, so now we're solving each of these factors. So in the first one, I have z squared minus 4 equals 0. I'm going to add 4 to both sides, get that z squared equals 4. Take the square root, and I get that z equals positive or negative 2. So there's 2 solutions there. For the other factor, it's in the quadratic form. So I need to think of 2 numbers that multiply to 16 and add to 4. So maybe it's 4 and 4. 4 times 4 is 16, but that doesn't add to 4. Okay, maybe it's 8 and 2. Well, that doesn't add to 4. And so maybe it's 16 and 1. That still doesn't add to 4. So I can't find anything, so I'm going to have to resort to the quadratic formula. So I'm going to do opposite b plus or minus the square root of b squared minus 4ac all over 2a. And this is solving for z squared. So opposite 4 plus or minus 4 squared, that's 64, minus 4 times 1 times 16. Sorry, I misspoke. 4 squared is 16. This piece right here is 16 minus 64, which is negative 48. Oh, a negative under the radical. It's going to be something imaginary. All over 2. I'm going to go ahead and just do decimals here. I can't put the negative in my calculator if I'm in real mode, so I'm going to go into imaginary mode, and I'm just going to input this into my calculator. So putting it into my calculator, I get that z squared equals negative 2 plus, I'm going to round, 3.46i. That's if I use the plus sign. If I use the minus sign, I'm going to get negative 2 minus 3.46i. Okay? So then to get both answers, I would square these, square root them, and that would give me my plus or minus. So I actually have 6 answers because I have z to the 6th power. So I have 2 from first factor, 2 here, and 2 there. Don't worry about simplifying, because we aren't really going to be doing this in Algebra 2 way. We're going to be doing it the pre-calculus way, which is part B. I hope that doing it the algebra way helps you to appreciate your calculus wise. So the original equation was z to the 6th power minus 64 equals 0. So to do this the pre-calculus way, we want to get z by itself. So we are going to add 64 to both sides of the equation. And we'll have that z to the 6th power equals 64. We're going to write that in polar form. So that's a complex number. If I think about graphing it, here's the real axis, here's the imaginary axis. The number 64 is a real number. So it gets plotted right here. We'll call that 64. And so if I think about this in terms of angles, that angle is 0 radians or 2 pi radians. So I can say that this is 64 cis 0, because that's the angle. And then to solve for z, I'm going to raise it to the 1/6 power. So I'm going to apply the nth root theorem here, and I'm going to get 64 to the 1/6 power, cis 1/6 times 0 plus 2k pi over 6, because the root is 6. That's why that's a 6 right there. And so notice that I have the k there, so I have to do this a couple times. Because I'm going to the 6th power, I have 6 answers. So I'm going to start with k is 0, 1, 2, and then I will also have 3, 4, 5. Remember, you stop at 1 less than n. All right, so starting when k is 0, I have 64 to the 1/6 power, cis 1 over 6, 0, times 0, plus 2 times 0 pi over 6, because k is 0. So I'm going to use my calculator to simplify this, and I'm going to find out that 64 to the 1/6 power, typing this into my calculator, that's the number 2. That's going to be the same for all of them, so I can just skip that step now for the rest of them. Cis 1/6 times 0 is 0. 2 times 0 pi over 6, that's 0. My final angle is 0. So that's when k is 0. That's one answer out of 6 total. So now let's do when k is 1. So when k is 1, my modulus will still be 2, 64 to the 1/6 power, cis. 1/6 times 0 is still 0, plus this number here, it's now a 1. So I'm just going to erase it and make it a 1. Now k is 1. So that's 0 plus 2 pi over 6, which simplifies to 1/3. That's my answer when k is 1. Now when k is 2. Modulus is still 2. This stuff here will still be 0. This is now 2 times 2 pi over 6. So it's now 4 pi over 6. Simplify the fraction, and it'll be 2/3. And you keep going when k is 3. The modulus is still 2. The modulus is the same for every single answer. And I'm going to go back here. This is still 0. This is now 2 times 3. K is now 3. 2 times 3, pi over 6. 2 times 3 is 6. Divided by 6 is 1. So it's just 1 pi. K is now 4. So I have 2 cis. This is still 0. This is now 4 times 2, 8 over 6. 8 over 6 simplifies to be 4 over 3. Remember, there's a pi there. 4 pi over 3. Last answer when k is 5. Modulus is still 2. And I have 0 plus 2 times 5 pi over 6. That's 10 pi over 6. 10 over 6 simplifies to be 5 over 3. So those are my 6 answers.